Dr. Prakash, we can start the session.
Yes, ma'am.
A very warm good morning to the Honorable Chief Guest and Speaker of the Day, Director of MCA and staffs. I cordially welcome you all to the Day 3 of Faculty Development Program. I extend my warm welcome to each one of you present here. Now I welcome Dr. M. Kannan, Assistant Professor, Department of MCA, to deliver the welcome address.
A very good morning to all of you. It is with immense pleasure I welcome you all to our esteemed faculty members. This event signifies our relentless commitment to academic excellence and growth. Our chief guest, Dr. Radhimala Kannan from Multimedia University, Malaysia, will inspire and guide us throughout this journey. We are also honored by the presence of our renowned principal, Dr. A. Punnusamy, whose visionary leadership and been instrumental in creating environment of learning and innovation. Furthermore, we extend a warm welcome to our director, Dr. A.V. Sendal Kumar, whose guidance has propelled our department to new heights and whose unwavering support for faculty development has made this event possible. Thank you, one and all, and join us today. Have a great day. Thank you.
Thank you, sir, for your warm words of welcome. Now I would like to call Dr. A. Prakash, Professor, Department of MCA, to introduce our eminent speaker of the day.
Good morning, one and all. Dr. Radhimala Kannan is an associate professor in Department of Information Technology at Faculty of Management of Multimedia University in Malaysia. She received her PhD from Multimedia University, Malaysia. Her research interest includes business data analytics, applications of AI and machine learning, data mining for business intelligence and information systems. She has been an academician and researcher for over 19 years and was involved actively in teaching, supervision, research, development of new curriculum, courses, and consultancy. She has published in many indexed top-tier journals such as Journal of Big Data, IEEE Access, and F1000 Research to name a few. Dr. Radhimala looks into the learning needs of the client and designed customized training courses in business data analytics using machine learning, which ranges from 1 day introductory course to 2 days hands-on training using popular open source data analytics software. Dr. Radhimala has conducted many corporate training in business data analytics and special workshops on data analytics using machine learning technique in the IEEE Humanitarian Technology Conferences and the online joint class with the Telkom University Indonesia. She is a Malaysian Human Resource Development Fund certified trainer who is engaged in training, consulting, and university industry collaborative projects. She is a senior member in IEEE and IEEE Malaysian Consultant Network Affinity Group and a professional technologist in Malaysian Board of Technologists. Thank you. Welcome you, ma'am.
Okay. Very good morning to you all. Am I audible?
Yes, ma'am. Good morning.
Thank you. Thank you. Thank you very much for the organizing committee, the principal, and the director of MCA department for having me here. Thank you very much. I'm here just to share my knowledge with you all about a research tool which is used for data science projects or data science research. Okay, so the one that I'm going to use is called S9 Analytics Platform, which is open source. Anybody can simply download from the internet. I think your lab already has that software. I'm not sure, Marina. So
Yes, Radhimala, we
okay,
have it.
okay. So I think, if possible, we can have a short hands-on session, because we have very short time, only 1 hour. So I'm trying to introduce a software and see what are the features that we can utilize from the software when you want to apply this software for your data science research. So without further ado, let me share my screen and start the session. Just give me a second. Okay, so NIME has recently introduced the latest version, which is called 5.0. So this is the NIME analytics platform. Um, Anybody heard about this before? NIME analytics? Those who are doing data science or machine learning related research?
Yes, ma'am.
Okay, thank you. So if you simply search in the internet, you will get this NIME, and once you download the software, this is how the software will look like. So this is the new user interface, because they have done some changes with the new user interface. So I will show you the new one also the old one also. Old one means not very old. Just before this June, we were using that old version only. Whichever version that you feel comfortable, you can just use it. Okay. So to start a new one, if you scroll down slightly, you will see a create workspace in your local space. Okay, so when you click this is like we are opening a new file or new document from NIME. Like any other document that you open, you need to give a name to save it. So the default name is NIME project. So now I want to change this as NIME HICAS FDP as the file name. So once done, I'm going to create this. So once I do, I will see my screen like this. Are you all following this, or you are just watching my screen? I repeat, are you using your PC or laptop? You're following me, the steps, or you just listening? Only observing, is it? Because I don't get any response. Okay, listening. Okay, very good. So now I've just explained that you can go through and you can just explore on it on your own when you have time or when you have a need to use this software. So if you look at here, this is the NIME user interface, new user interface. The dotted space on your right is called as the working space. So you can create a workflow. A workflow means the steps that you carry on to do a certain activities related to your data science project. Okay, so now what I'm going to do is the very first step in data science is we need the data. Am I right? So I have a CSV data. So I want to read a CSV data. So what I can do is, if you look on the left hand side, this is repository. The repository gives you all the comments in a drop down format where it are categorized based upon their types. For example, IO stands for input output. So here you can find all the comments related to reading a file or writing a file. For example, if you want to read an Excel file, we have an Excel reader. Or you want to write into as an Excel file, we have an Excel writer. So similarly, you can even read directly from Google Spreadsheet by authenticating your credentials. So you can use Google Spreadsheet. You can read CSV reader, CSV writer. If you click this show all, you will get all other different file formats that you can work with NIME software. For example, you can get the data from SharePoint, Microsoft. You can have a table reader. You can read a list of files and folders. You can even have JSON files. There are so many different type of files here. So I just focus only on IO now. So I just click IO. So the very first step is my requirement is I want to read an CSV file. So what I'm doing is here I have a CSV reader. We call this as a node. Okay. This CSV reader node, simply I can drag it and I can drop it. That's all. See, remember this NIME Analytics, it is a low-code data science software where most of the common tasks are already automated. Since you are all from computer department, you know how to write functions. When you know how to do the programming, you can write your own functions, user-defined functions, and you can use it in multiple times. You can call the functions in many times and you can use it by passing the right parameters, right? So exactly same thing whether you do it in Python or you do it in R, here it is already written and it is already in the executable form. So that makes us easy. We don't have to write a single code, simply drag and drop well enough. So if you look at this, okay, so I'm having a raised hand. Is there any doubt? Lalita, Shalvira, is there any doubt? Please stop me if I go faster. Is there any questions for you, Lalita or Shalvira? Is it Saravanan? So if you don't have any cows, you please put your hands down. Huh? Okay. So now here, this is the node we call. So when you put your cursor there, the first one is the settings or configuration. So you can give the configuration. When we say configuration means you're passing your parameters to the function. Okay. Then here the triangle, it is the execute where you can execute the node. And here you can delete or cancel your execution. So this one is you can reset the node. Okay. So first I click the configure. So when I click configure, you can see a new window pops up. So here, if you look at here, the purpose of this node is to read a CSV file. So I have to provide the path of the CSV file related to my laptop, right? So like opening up any file, you can click this browse. Okay. Then you select your file, whatever the file that you want to open. See, actually now I have a file here. So let me locate my file. So this is the data set I want to open. I click open. The moment you select your file, if you scroll down on the configuration window, you can see the preview of your data set. So you can ensure whether all the column headers are correct, all the data are correct, this is the right data, whether the software has read your file correctly. That means one column, you have the one attribute. If you think everything is fine, you just click OK. Okay. The moment you click OK, you can see the color changes into yellow color. This is like signal. When it is red color, the node is not yet configured. When the node is in yellow color, the configuration is done. Just now we have did the configuration of locating the file. Then we need to execute. So to execute, I simply click this triangle. So now I can see a green color at the bottom of the CSV reader, which says the node is already executed. So now I can see the results. At the bottom of your screen, you can see the results. So if you want to have a bigger screen, I just open us like this. Okay. So here you can see the details about the file that I just now read. So is it readable to you? Is my screen is readable to everyone?
Yes, ma'am.
Thank you. So maybe I slightly zoom in so that you may get better. It's clear? Thank you so much. So now if you look at here, the first moment I get the details, this file has 72,270 rows. Yes? Okay. I repeat, if you have any doubt or you want me to say it again, you please stop me there itself. Huh? Okay. So now I would like, okay, I know there are 72,000 plus rows. Okay. I would like to see what are the attributes I have here. Okay. So when I click this Here I know all the variables that I have. Okay, so this one about customer service for some subscription product. So the customers, they can subscribe for TV subscriber. This is like, something like your Netflix. So I have attribute where I can see whether the customer has subscribed for TV, subscribed for movie package. Then I have how long they are with us as a customer. So this would be a number of years. Then how much is they are paying as a monthly bill. So bill, average bill. So I have these details. Then how much time remaining contract, which is in number format. Then I have service failure count. How many times the customer has complained because of the service failure, and how many times this customer, each of these 72,000 plus customer, on average, how much they have downloaded, how much they have uploaded. Then also I have whether any customers download over their limit. So we have custom details about that. Then finally, I have whether the customer churn or not. A 1 represents the customer churn already. A 0 represents the customer is not churn. So what does it mean? This is, we consider this is a Netflix data set, assume that. So we have customers who have subscribed for TV or movie packages. Then we know on average how much time they have downloaded the content, they have uploaded the content, whether they have over the limit, they have downloaded more than their limit, and all these details we have. Okay, with these details, we also have an important information that among these 72,000, how many customers churn and how many customers are not churn. So churn means what? They are not happy with the company, so they terminated their contract or subscription with the company. They move on to their competitors. So now this data set basically focuses on customer churn prediction, trying to predict which customer will churn in the near future. Okay. By looking at this, those who know data mining, you already know this falls under supervised machine learning problem. So again, either you can treat this as a classification problem or you can treat this as a regression problem as well. Okay, so since I want to predict, I want to classify whether a customer will churn or not, I'm going to consider this as a classification problem, and I'm going to show you how you can build a complete data science cycle with this data set, and how do you fix the problems that you have with the data set, and so on. So far, okay? Okay, thank you so much. So now, apart from this information, the moment you read the data, I can also get the statistics, basic descriptive analytics of the data I have. So when you click this statistics tab, so now the statistics are calculated for this particular data set. So if you look at the statistics, I have missing values. So that is the first step we do in data science, right? You need to assess the quality of the data set. You have to see, is the data is noisy data, or do you have any missing values, inconsistency, and all those stuff. Okay. So here I can know there is a missing values. Then I know how many unique values are there. So if it is a numeric attribute, then I know what is the minimum value, maximum value, 25th quantile, 50th quantile, and 75th quantile, and so on. So if you want to restrict these so many statistics, we can restrict, we can find whatever we want also. So I'm going to calculate the statistics, only those statistics which I want to see, not everyone like this. So for that, what I'm going to do is, I'm going to just expand this link. So this feature is available only in the new NIME workspace, new NIME user interface. Okay. So the moment you drag this line, then it will show you the list of possible nodes that you could use. Okay. So now if you look at here, you have table splitter, table cropper, column filter, row filter, partitioning node, that means splitting the data into two sets, all those stuff. So now I am interested in this statistics. Okay, because I want to see those statistics which I want to see. Okay, so once I connect the statistics, now I need to do the configuration. Every time when I open a statistics node, I have to see the configuration. Okay, so now by default here some of the files are left out. So I just want to include everything on the right hand side. So when I click this double arrow, all the variables from the left will come to the right because I want to know everything. Okay, then here the basic number of columns, number of rows in a column is 1000. This is a default setting. Since my data set is having 72,000 plus, I am increasing the number of rows here as 73. So as the number of unique frequent values, since my number of rows is high, I'm increasing the number of unique values that is possible from that also, 200, 2000 or whatever it is, just an approximate figure. Okay, once I do this, I also want to calculate the median value. Okay, because sometimes I not know whether my data is normally distributed or it is skewed distribution. So in order to understand my data, I need to calculate the median value as well. So I click all these things. I click OK. So now I have configured now. So the next thing is I can execute. Since I have 72,001, so it takes a bit time because we are calculating all the possible descriptive analytics. Okay, so if you look at here, so I have the minimum value or maximum value for each of the, is it readable? Maybe I just increase a little bit. Thank you.
Yes, ma'am.
Thank you. So now if you look at here, for all the numeric attributes, the software automatically calculates what is the minimum value, what is the maximum value, what is the mean, standard deviation, variances, skewness, kurtosis, and also the number of missing values. Number of missing values and no nans. So all these things you can avoid, and we have the median as well. Okay. So now, if I want to explore further whether the data is normally distributed or not, I need to compare this mean and median to see is there any much differences between the mean and median, so that I know whether the data is skewed distributed or normally distributed. Or even you can see from the histogram image to get to know whether the data is normally distributed or skewed distribution. Okay, so now what I'm going to do is from this I want to switch on to the classic mode to see how the interface is like that in classic mode. Okay, so what I'm going to do is to switch on from this new interface to classic mode. Here you have an eye. Okay, so if you click that eye, which is information, and scroll down a bit, you have the option switch to NIME classic user interface. Okay, so when I click this is the classic user interface which we have been using for so long. Okay, so again, now if you see, this is much more comprehensive and much more easier for me because I'm already familiar with this. So here, if you look at the user interface, so here the one we have the same NIME project, NIME HiCAS FDP. So on the left hand side, I have the NIME Explorer. NIME Explorer is like your Windows Explorer, the folder where you save all your files. So here you can see, okay, I have the NIME HiCAS FDP, which I have created just now, right? So at the bottom, I have the window which lists out all the node repository, just like you have seen. So you have seen like in a graphic form, now it's listed form. So I have IO, input, output, I have read option, write option, connectors, and so on. So when I click the read option, I have all the node which can read various file formats. So Excel reader, file reader, RFF reader, CSV reader, table reader. PML reader is predictive modeling markup language. It's a model reader. Then so on. You have here many options you have. Of course, you can explore. Okay, I just want to show you these are all features is available with this NIME software. So if you find that it is interesting and you want to teach this to the students as well, it will be a very good tool, especially for those who are not so good at programming or find programming is very tough. You can see this as an alternative research tool. Okay, so I have already read. So this is the statistics node. So now if you look at here in the classic interface, when you keep your cursor, you will not get that configure, executing the file, everything, which you can get it by right clicking the row. So when you right click, you can configure, okay, you can execute, and you can see the result. Since we have already executed this node, and this 3 triangle here indicates there are 3 different type of outputs from this node. Okay, so now when I click here and I just click the first one, the statistics table will list out all the numeric attribute descriptions. The nominal histogram table will list out all the categorical variable or nominal attribute, or we can say string variables, since everybody is no programming. Okay, so let me look at the statistics. So this is the statistics node output. Okay, so I find the classic user interface is much more easier to do the work because I can maximize it. I can see what I want with the one full screen. Whereas in the new user interface, it splits the available screen space, and it gives you some at the bottom. You have the results, at the top you have the workface interface. So that is quite difficult for me unless you have a very big monitor to view this. Okay, so now here same like here you have minimum value, maximum value, you have median, standard deviation, variances, skewness, kurtosis, overall, missing values, and so on, along with the histogram, also the median value. So now what I want to do is I want to bring this median and closer to the mean, so that I can describe this data much more better. So it says that is TV subscriber. So there are 2 values only, 0 and 1. Okay, the mean is 0.815, the median is 1. So since the median is 1, what does it mean? Most of the customers from this data set, they have subscribed for TV. Whereas if you look at the movie package subscription, the median value is 0. What does it mean? Most of the subscriber here, they have not subscribed for this movie package. Okay, so we have subscribers who are interested in TV or who are interested in movie package. And similarly, we have a subscription age. Maybe let's say if we consider this as in terms of years. So minimum is negative figure. So there is something wrong with the data set. Maximum is 12.8 years. The average bill amount is ranging from 0 to 406. Remaining contract, the period, so from 2.92 years. Then how much they are uploading, downloading, average, and those things. Then also we have the data, how many customers tune or not. Okay, so this is the description about the data set and the respective histogram. So when you look at this histogram, service failure count, we can clearly see it is as highly skewed distribution. Correct? So let's look at the mean and median value. So the mean says 0.274, whereas median says 0. So what does it mean? How we can conclude? Most of the customers, they have not faced service failure. Only very few customers, they face a service failure. That is the reason you get mean value this. And if you look at the histogram, it's very clear the data is highly skewed. Okay, so when you want to take the average, when you want to describe this data set, we can describe that most of the customers, they have not faced the service failure. That's how we will report the description. Okay, so this is the first step, describing your data set. Okay, so that's it. I will stop the description about here. Next, we move on to the data understand or data pre-processing. Is it possible to increase the tables for that node, or is it fixed? What do you mean by increase the tables means? Okay. Reshmi, now only I'm seeing your question. How to switch back from classic node? Same thing. If you want to go back to the new user interface, can you see open 9 modern UI user interface? By clicking this, you can go back to the new interface. So which one you all like? You like the new interface or the old interface? No question? Classic one. Thank you. So now, is it possible to increase the tables for that node, or is it fixed? I don't understand your question.
Ma'am, actually, in that statistics node, we have 3 arrow marks, no, ma'am.
Yeah.
And each one represents one table. Am I
Correct.
right? Okay.
Correct.
Is it possible to increase the tables, or is it fixed that we should only accommodate with the 3 tables?
Okay. When you want to do the statistics, there is only 2 possibilities. Either you have a string attributes or you have a numeric attribute. Am I right?
Yes, ma'am.
When you work with it. Okay. When you work with the data, I'm talking about the structured data, not unstructured, semi-structured. Okay. When you work with the structured data, you will have either numeric attributes or string attributes. So that's what the statistics table will give you, the description of numeric attribute. Nominal histogram will give you the statistics of string attribute. Since in my data set, there is not much of a nominal histogram, so I'm getting like this. Since it's 0, 1, 1, it is giving me like this. Okay. But now if you look at the third option, that's the occurrences table. So the occurrences table means it will give you the frequency count for each of the attributes that you have in your data set. For example, look at this. Is TV subscriber. So in your data set, there are 58,922 customers have subscribed for TV, where they make 81.5%. So this is the relative percentage. Do you get that? So the occurrences table will give you the count, frequency count, both in the count form, also in the relative frequency. So when we report, when we describe this data, we can see 81.5% of the customers, they have subscribed for TV. 18.5 they have not subscribed. Similarly, if you go for movie subscription, see 66.5% of the customers, they have subscribed for movie packages. Remaining they have not. So like that you can describe. So the statistics node is mainly focusing on exploratory data analysis, where it gives you the standard statistics description. Again, if you look at the tune, which attribute that we are interested in. So this data set says 55.4% of your customers, they're all unhappy customers, they churn already. So your loyal customers are less, 44.6%. So this is very danger for any business which deals with the retail customers, right? The number of customers who are not happy with their service or product is high. So they have to do something to reduce this or try to retain their customers. Okay, that's what we are also going to do, coming up with the prediction models to predict which customer will churn and which customer will not churn. Okay, so these are the 3 different outputs But there are certain nodes where we can increase the number of output depending upon our need. Okay. Thank you. So the next one, since I'm not focusing much on exploring the data set, now focus more on machine learning related thing. So let's say we want to build a prediction model. So right now we noticed, if you look at the statistics table, a number of missing values. Okay. So I sort this number of missing value in descending order. Okay. So if you look at here, the attribute remaining contract, it has 21,572 missing values. Remember, we have 72,000. Okay, so this is the total number of rows we have. Among that, this many is already missing, which is more than 20%. So as a rule of thumb from data science practitioner, if we have more than 20% of missing value, then that attribute is not going to give us much insights for our problem. So we can decide to remove. But on the other hand, if you look at the download average and upload average, these two attributes, they show very minimal level of missing values, 381. So 381 out of 72,000 is very minimal, right? Less than 10%, I can say. So we are less than 1% in fact. So what we are going to do is we try to do some missing value imputation techniques to handle this problem rather than removing the entire rows or the entire column. All right. So since this scope of this session is just to introduce the tool, not about the subject, so I'm not going much about the data science concepts here. So understanding that I have some missing values, now I have to do two things. One is I need to remove the attribute which has high missing value. The second one is I have to impute the other two attributes. Okay. So what I'm going to do is, first thing, I have to remove the variables that I don't want to include in further analysis, which I can do using a column filter. Remember, each of the attribute refers the column of the table, right? So we want to remove two columns. So filter column. So you have a node called column filter. Okay. So drag it and drop it. So in the column filter, you just connect it. The connecting is very easy. Just click here, hold down your mouse, drag it and drop it here. That's all. Now you open the configuration of this column filter. So which looks like this. Okay. So now on the right hand side, you will have all the attributes that you have in your data set. So what I don't want this ID because the customer ID is not going to give me any insight. So I'm going to remove customer ID. The second one is remaining contract. So I'm removing these two. I'm filtering these two columns. Okay. I click OK. Execute. So now I want to see the processed data, which I can see here as the filtered table. Okay. So now if you look at here, initially I had 9 columns. Now I have only 2 columns. I mean, less than 2 columns. So now I have, initially I had 11. Now I have 9. Okay. So when I click this columns, so these are the columns that I have. Okay. So I know the type of the column. Also, since everything is the numeric one, I know what is the minimum value and maximum value of each of those attributes. By when you look at this, you can figure it out. Is there any absolute value? Something is fishy here. Okay. So when you look at here, TV subscriber, I have 0 and 1 because it's only yes or no, Boolean type. So here also only 2 types. But when you look at the subscription age, I have a subscription which is minus 0.02, right? So how is it possible to have a subscription age like this, the lower value? So it could be either 0 or higher than 0, right? It cannot be negative figure. You all agree? So we are exploring the data now. So now what I want to do is I want to filter those rows which has this negative figure. Okay. So how I can do this? So now I want to deal with the rows because I want to split the rows where the rows which has negative value of this, what is that variable? Subscription age, right? I want to remove that. So for that, like row filter, now I have like column filter, now I have row filter because I want to filter the row. Okay, so here I have a row filter. Okay, so now as usual, the first step we bring the node, next step is we need to configure. So when you configure, now you see at the top which variable based upon which attribute that you want to filter your rows. So I select subscription age. Okay, so the subscription range, since it is a numeric variable, I'm not going for any pattern matching. This is applicable to a categorical variable. So I'm looking for numerical. So I'm clicking the use range checking. Okay, so I'm giving the lower range is 0. Okay, so then on the left hand side I'm saying include rows by attribute value. So include all the values where the lower range is 0 and upper range could be anything, right? The more higher, then we have a loyal customer with us. I just click OK. I execute. So now I have a processed one. Okay, so let me look at the column now. Oh, I have to exclude. I don't want to include, right? 0 to, let's say I gave some 100. Subscription age. Okay. Okay. Execute. Filtered. Columns. Still I have the subscription range. So let me say .1. Okay. Okay, so still I'm having this. Let me sort out this and see whether I have the subscription age which is in negative figure. So I'm sorting it in ascending order. So when I start in ascending order, so my first value is 0.1. Can you all see this? Whereas before I do the row filtering, in the column filter, when I do the subscription in ascending order, the first value is 0.02. So this is the only customer I have. There is only one customer whose subscription age is 0.02. Okay, so this may be a data entry error. Okay, so we can remove this using the row filter. So since it starts from 1, so I go with 0. Okay. Okay, execute. So now I have filtered the row. The next thing, okay, so now if I put the statistics node, I will not have the first 2 rows attributes. The next step is I have to filter the missing values. Remember, we have 381 rows missing for 2 variables. Okay, to handle that, I have something called missing value. Okay, So in the missing value, you know that there are different ways that we can impute the missing values. Okay. So right now from the data set, I have only two types of attribute. One is integer, other one is double. Okay. So I can tell how do I want to treat the missing values from these data types. So since I don't want to change the data distribution, I want to go for median for both. Okay. Replace the missing value with the median value of that particular column. Okay. So I select median. So I'm handling the missing value here. I execute. Okay, then let me see the output table. Okay, so again, if I want to see do I have missing value, I can attach the statistics node. I just copy and paste it here rather than dragging it from here. Either way you can do. Okay, so the black color one is your data. The blue color square box is actually the model which keep tracks how you change your missing values. Okay, so I connect here, open the configuration. Okay, so these two are not here now because we have already removed, so no worries. So I click OK, execute. So let me open the statistics table because all my variables are number. So now I need to focus on my missing values. So this is my missing values. You see, I don't have any missing values now. Can you all follow me? Am I clear so far?
Yes, ma'am.
Okay, thank you. Okay, so now we have already handled our missing value problem. Right now our data set is ready. That means our data set is cleaned. It is not yet processed in the way that we want. Okay. So once the missing value problem is quality of the data is fixed, next one, we need to process our data so that we can apply to the machine learning model. Okay. So currently when you look at the data, so this is how my data looks. All right. So this is the description of the data. So the first thing what I want to do is, since I want to come up with a classification model, I want to change this data type from number double to a categorical, to a string, where 0 represents customers who are tune equal to false. This will be false and this will be true. Or I can say this is yes, this is no. Tune equal to no means he is a happy customer, he is still your customer. Tune equal to yes means he is an unhappy customer, he already tuned. So far, okay. So now this is called as data encoding, or what do you say, transforming new variables, though you call different names. What I'm going to do is, I want to create a new variable based upon this variable. So to create a new variable, I have something called rule engine, where I can define the condition. Okay. So the rule engine, so the clean data, the black one, I'm connecting to the rule engine. So in the rule engine, the first I'm converting, here I can document it, tune in category form. That's what I'm going to do. Currently the tune attribute in a number format, I want to convert it into category format. Okay. So now I double click, or I can open the configuration. Okay. When I open the configuration, which one I want to change? This tune variable. Right. When you double click, this is like a small coding. When the tune value is equal to 0, then I want to convert that as no. Right? No means what? The customer did not tune. Similarly, if the tune value is equal to 1, Then I want to call this as, yes, that means this customer churn already. That's all. Okay. So now there are two options I have. One thing, I can create a new variable, new attribute, and I can give a new name, or I can replace the existing one. Okay. For this case, let's say I'm replacing the existing column. So I want to call this into churn. So far, okay. So now I click OK. I execute. If you look at the result, classified table, I'm looking at the column. Now you can see the churn is not a number, it is a string variable with the yes and no as the values. Correct? I'm sure you would have done all these kind of steps using either Python or in R. So here you can see how much easy it is to use the standard type of activities that you will do in your data science projects. Okay. So far, okay. Any doubts so far? Am I going very fast? Or still you can follow me? Okay, still you can follow me? Okay, so let me introduce others. So we have done one. Okay, we created a rule engine. The next step, what I want to do is, if you look at the data table, since I want to use a classification problem, I want to convert this Boolean type 0 and 1 into yes and no. Okay. So this is useful for me when I use a decision tree algorithm. Okay, but if I use a neural network algorithm, then I need to keep this variable in numeric form, because you need to then your neural network will accept attributes in numeric form only. So there again I have to do data encoding. So what I'm going to do is, I'm going to create a new variable using the same rule engine. Okay, so this time I want to say is TV subscriber. If the value equal to 0, then I want to call them as no, because these customers have not subscribed to the TV package. If the value is equal to 1, then I say these people, they have subscribed for the TV package. Okay, so now I don't want to replace this column, because later I need this in a numeric format for applying other type of machine learning algorithm. So I'm creating a new column. See, append column. So here I can give a name. So I'm giving this same name is TV subscriber, but underscore yes, so that I say this is now in string format. So I'm creating a new variable now. Okay, so click OK, execute. So now you might see we will have one new attribute. Instead of 9, now we will have 10 attributes. Can you see? We have totally 10 columns, 10 attributes here, where you have each TV subscriber, one in number format, another one is in string format. Okay. Okay. So similarly, you can carry on. Let's see if you don't, sometimes from the category, if you want to convert into a number, we have label encoding, we have one hotkey encoding, everything is also here. Okay. That is also possible. We have the relevant nodes here. Okay, since that is not related to this data set that I'm using now, I'm not covering those things. Okay, so we have done rule engine. Assume that we are fixing with that here. Now we want to build the model. Okay, so since we are coming up with a supervised machine learning model, we need to partition the data set. Okay, so we need to split the data set into training data set and test data set. So we have a node called partitioning, which makes two partitions. Okay, So while you make the partition, if you open the configuration, you have option how many percentage you want to partition. So the first one, choose size of your first partition. So I can choose 50%, 70%. Assume that I'm going to use 70% of the data to train the model, remaining 30% of the data to test the model. Okay. So I'm splitting the data into 70-30. And also the sampling method. How are you selecting those training data? What sampling method you are going to use? So we have various sampling method. Take from the top first 70% or use linear sampling, or you can draw it randomly. But since this is a classification problem, I need to have both the classes representative in the training data set. So I'm choosing the stratified sampling. Then I'm stratifying the data based upon tune, because that is my target. Okay, so I click OK. So now I have executed. I split the data. If I put my cursor here, you see out of 72,000 plus 50,000 is assigned for training data, the first partition. Remaining 21,000 plus is the test data set. But you all know for data mining we need 3 data set, right? Training data set, validation data set, and test data set. Okay, so I'm going to have one more partitioning node. Okay, because I need 3 data sets. So I'm going to repeat the same thing. Again, 70% is stratified sampling. Okay, execute. So now this one is the training data. This one is the validation data, and this is the test data set. So now I have 3 sets of data set. So I have splitted the data set. The next step is build the prediction model. So I want to use decision tree algorithm. So if you look at what are the algorithms that are available. So if you look at here under analytics, you have mining. If you click mining, you have naive Bayes, clustering, rule induction, neural network, decision tree. You can do ensemble method. Okay, you have lots of method here. And if you click each, you will have further. For example, if you click a clustering here, you have a DB scan, fuzzy C means hierarchical cluster. There are so many. Of course, you can explore everything. Even if you click neural network, we have MLP and PNN, multi-layer perceptron, and also probabilistic neural network methods we have here. Similarly, if you go to decision tree, we have decision tree learner, also decision tree for regression model. You have simple regression tree, then you have random forest, ensemble learning, you have random forest, XGBoost, most of the popular machine learning algorithms are available here. Okay, so now I just continue with the decision tree. I just want to finish it off with showing one complete model, prediction model. Okay, so decision tree learner. So supervised learning, you all know there is a learning. That means you need to train the model first, validate, then hyperparameter tuning, then you test the model, right? So first we train the model. So when you train the model, go to the configuration. So select your target. Our target is Chion. Okay. So the quality measure here, we have 2 quality measure, Gini index, also the gain ratio. So you can play around this when you do the hyperparameter tuning here. Okay. So I go for gain ratio. When you execute, this is the model build. The blue color box is the model. Okay. There's a PMML model, predictive markup modeling markup language. So once I train the model, here I have the validation data set. I need to validate whether the model learned properly and what is the training performance of the model. So to do that, I make the model to predict the validation data set. Okay. So then I execute. I open the configuration. I make sure everything is correct. Nothing to do here. I executed. Okay, so once you execute, now we need to calculate the performance evaluation measures like accuracy, precision, recall, F measure, and so on, right? So That one can be calculated with the node called scorer. Okay, so we have a scorer node. So just connect here, open the configuration. So fix your target and your prediction. So this is correct. I click OK, execute. So this is my accuracy statistics. This is the performance of the model. The first 4 is your confusion matrix. So I'm not going to talk about confusion matrix, but rather you can see recall, precision, sensitivity, specificity of measure, accuracy, and Cohen kappa. So since you all know the data science concept, I'm not going to much. So now when you look at here, since our data set is relatively balanced data set, because 55% are churn, 45% are not churn, right? It's a kind of a balanced data set. So still we can consider our accuracy. So this model, the training performance of this model is 76%. Okay. And if you look at the F measure, this model can correctly predict the churn with 78.4% of accuracy, and those who will not churn with 74.3% of accuracy. This is a training performance, right? So now we need to validate. We need to test. For testing, again, I need these two. So instead of taking it from there, I'm just copying and pasting it here. Okay, so for testing, I need to give the model that we trained just now. Then we need to give the test data set. Remember, this is the first partition. We have the test data set. This data set still the model has not seen. This is a new data set according to the model, because the model got trained with this training data set and improvised by parameter tuning uses validation data set. So here is my test data set. Let us see the performance of our test data set. We are evaluating the model actually now. So when you evaluate the model, what you can see, so still the performance is good, 76.3%. And if you look at the F measure, slightly lower than your training performance, but still it is okay, not very bad. Okay, so this is just one flow. Then you can do hyperparameter tuning and so on, change the partitioning ratio, change the quality measure. By doing all these things, see whether your performance of the model is increasing or not. So we just do with one machine learning algorithm. So now you can apply other machine learning algorithm to predict the same customer churn, then compare the performance of the model and select the best one for the next deployment stage. So this is the one complete cycle of doing your data science project. I have touched upon reading it, exploring the data pre-processing, partitioning, and applying machine learning to train the model, validate the model, and test the model. Okay, I think I will stop here because it's already 1 hour and I have a meeting at 2 o'clock here. So you can ask any questions. Maybe we'll spend 5 minutes for any question answer. Any questions you want to ask?
Ma'am, what are the application for the 9 analytics tools, ma'am?
What is the application, is it?
What are the applications? Yes, ma'am.
Any data science project you can do with 9.
Okay.
Yes, it is a data science platform.
Okay. Your presentation is real-time presentation. Very nice, ma'am.
Thank you.
Okay.
I have almost more than 5 years experience of doing working with this software, and I find it interesting. I have worked also with a RapidMiner, also recently SAS Via, and I have worked with Veka also. And of course, I do programming with Python and R, but since my focus is on getting this data science to the business people, corporate companies and all, I do lots of corporate training. So introducing them with this software is more easy for them to understand. And those who do not like programming, even not only the computer science students, you leave the computer science, other students also can learn, they can apply. they can use data science to extract the insights from the data, try to solve the business problem.
I think this one very helpful for the MBA project. I think.
Exactly. I do teach
For
MBA here and I use
yeah,
this only for MBA students. Yes.
because I am standing in B school only, Department of MCA staff, Vivekananda College. My name is Ponnai.
Hi.
Okay, thank you.
I teach to because here I teach mostly for the business management student as well. Teaching them programming or data science, data mining, they are very scared first. So we have to bring it as much simplified as, because they are the one who will really use this software, this kind of insights to solve the business problems, right? So they have to see there is alternative way to look for solution for their business problem from the data that they have itself. So it is very important for the MBA students or any other students also to know the value of this data science.
Same thing in SPSS tool also they are using, ma'am. Statistical.
SPSS is statistical package. Statistical package for software programming. That one do not have all this machine learning part. Of course, you do have clustering, hierarchical clustering. I think now they introduce the k-means also, but you will not have a neural network one or other SPM. Those kind of machine learning part algorithms are not available in SPSS. Yes,
ma'am. Thank you very much for precious time spent with that, ma'am.
Thank you everyone.
I know your time, because this is the afternoon session, I think 2 o'clock, 1:30 I think.
Yeah, it's 1:30. Yeah, I have to go to office now. Okay, yes, so somebody is asking, is there any website or tutorial for studying? Yeah, this is an open source. Okay, let me open a tab and just bring it here. Okay, if you see NIME Analytics, okay, this is the website. Okay, it is open and free, coding optional, always extensive. This is a data science platform. From start to end, you can do. There are so many things you can do with this software. Please go through this website. There are lots of materials available. Lots of case studies, use case studies are available. Whether since you are business people also here, whether you are teaching for finance analytics or some other economics, whatever it is, all the use case studies are here. Okay, also for the IT computer science students, if you want to work with unstructured data, semi-structured data, you want to collect data, crawl data, or you want to pull the data from various databases and you want to integrate it and you want to do the cleaning, many things you can automate here. Okay, this is a very interesting tool that I found from my 20 years of experience in this field. Okay, any other questions? In which language this NIME was developed? Okay, I'm not very sure. I have not explored that. Okay, how to switch back? I think no, there is no other questions. Okay, you can ask me any questions if I missed from the chat box. Okay, so if there is no question, let me start presenting it. And I would like to thank you one more time for having me here.
Ratimala, thank you so much.
Yeah.
The session was very interesting.
Thank you.
Hope all the participants have gained good knowledge on the application side of it.
Yeah. So I type my email address here in the chat box. So anybody who wishes to have any connection or anything, they can contact me here. Huh?
Yes.
Yeah. Vanaja Muttayan is raising the hand. Any questions? No?
No. Prakash sir, can we come to a formal vote of thanks?
Yes, ma'am.
Thank you.
Thank you, ma'am, for such a valuable and thoughtful information. Now I would like to call Dr. V. Sulojana, Assistant Professor, Department of MCA, to render the vote of thanks.
Good morning to all. Uh, I stand here today as a proud and a grateful faculty to express my heartfelt thanks to all those who have made this third day FDP a possible event. And I also thank the management who always have been a supportive of our initiative and encouraged us to strive for excellence. And I would like to express my appreciation to our chief guest, TS Dr. Ratnamala Kannan, who have taken time out of her busy schedule to grace this occasion with her presence. Ma'am, your presence has added an extra spark to this FDP and made this even more special. And I finally thank the students and the faculty members and the other outside participants who made this third day FDP program a grand success. Thank you, ma'am.
Thank you. Thank you, everyone. Bye bye.
Thank you, everyone. Please fill the feedback link.